Hi there, you're in the lab with your mate JJ. Today is Maxitronix 30in1 day. Today we're going to be working through the Maxitronix 30in1. This is it. It's obviously an electronics project kit. It looks like this. We're going to be popping over to the booth and we're going to wire this thing up, and then we're going to pop over to the bench and have a look at how it behaves. This is project 1. This is the first of 30 projects. We try to get a project out for Maxitronix every Thursday. So Thursday is Maxitronix Day. So this video should be coming out on Thursday, which is actually tomorrow. Trying to get on top of the recording and publishing and scheduling of the videos around here so that I have 3 videos a week. Tuesday, Thursday and Saturday. With the 30in1, of course, we've already done the 10in1 and we did the Sensor Robot 20, which we called the 20in1. So those are done. We're just about to get started on this 30in1. This is the first project today. I did the introduction video earlier. And I thought that we might do something new. I was going to do an LT Spice simulation of the hardware. But I found recently that the latest version of KiCad, version 9, has some like simulation like features in there, and I'm not sure how good they are, but I thought I might give it a go. So what we're going to do today is we're going to jump onto the computer together and see if we can make the circuit in KiCad, and if we can simulate it in any way. I'm not sure how you apply a test signal or voltage or whatever. I don't know what it's going to do, but let's find out together. So let's jump over to the computer and we'll have a look at the schematics and such. Once all that's done, we'll do the construction and the testing of the actual hardware. So let's do the computer first.
Alright, so here we are on the computer and we're on the ITL wiki, which is in the labwithjj.com/wiki. Today we'll be working on our Maxitronix 30in1, which is here, and I've made some notes for the very first project, which are here. By the way, this is the project page for the 30in1. There's not much here yet. Here's the introductory video that we did a while back. And then this is a note about the components on board. A couple of capacitors, diode, earphone, LED, some resistors. Not sure about the auto transformer. I believe it's called an auto transformer when it's only got the woman winding attached. So not quite sure about that. The transistors are NPN transistors, and there's a tuning capacitor. So this is the box that it came in. This is the unit itself, and here is the front cover of the manual. So we'll be going through electronics project number 1 for that today. But as I said before we begin, we're going to do a model of the circuit board in KiCad. Now let me just show you. These are the instructions which I scanned earlier. Because it's the first project, it's got this whole blurb, this whole write-up here. You can click through on these details and have a close read of that if you're interested, but it just basically talks you through setting up the first schematic, which is this. And then this is the wiring sequence that those instructions give you. So that's what we'll be using today. And you can see overall there's a whole lot of it on one page. It's all been split out above. So this is the whole picture. This is the circuit that we'll be building today, and we're going to build it over in the lab, in the booth, in fact. But before we do that, we're going to run a simulation of this circuit. So that's something I wanted to do with you now, which is what we're going to do now. So I'm going to put the circuit in the corner there, and then I'm going to open up KiCad down here, and we're going to do a new project. This is the one I did earlier. I did a proof of concept, so I know what I'm going to be showing you. We're going to call this Maxitronix 30in1 -2. So let's do that. All right, and I made myself some notes. We'll try and bring up my notes as well. Those are here. So I'll just drag that over to here. Alright, and we'll see if we can squeeze it all in. So, we've got the circuit we're building here, and we've got some instructions about the order of things over here. So that looks pretty good to me. I think that that will be workable. So let's do the thing together. So the first thing to do is to add. I might try and use the mouse rather than the shortcut keys, just so that you can see exactly how everything is done. So we're going to want to add, that's a wire, that looks like a component. Yeah. All right. So we add a component, and we're going to be adding a 1.5 volt voltage DC, VDC, and we're going to use the one that comes in the SPICE simulation. So because we're doing SPICE simulation, I think we need to pick the bits that support it. So there's going to be 2 of these. So we'll place one, and then how do we look? I'm gonna tell you about my shortcut keys. I'm using Pat Deegan's shortcut keys. I'll put a note in the show notes, and I'm just going to tell you the keys. I'm learning them at the moment anyway. So I'm going to press W for duplicate, and I'm going to put another voltage source here. So this is the main voltage, which is V1, and it's going to be 1.5 volts. I'll just put the volts in there. Okay. And this one is going to be a pulse. It's -5 +5. So let's do that together quickly. So we're going to change the SPICE model, and we're going to change this to pulse, and then we're going to go from -5 to 5, 0 delay, 1 microsecond rise time, 1 microsecond fall time. Pulse width is 50% duty cycle. Per period 1. No number of pulses, it can just keep on pulsing. Okay. So there we've added that. Oh, and I'll just get rid of the, oh, that's not what I want to do. I just want to jump in here. And we don't want to show that or that. That's fine. All right. So there's our 2 voltages. Now we're going to have to add in, so we're going to click add, and we're going to add 0, which is the ground, the 0 volt reference for SPICE. So I'm going to add a 0. We're going to add it here, and I'm going to press duplicate again, which on my setup is W, and I put that there as well. All right. Now let's zoom in. I press Control Home, and that'll just bring things a bit closer together. So it says add that. So we're going to add 3 resistors. So that's A, and then R, and the resistor, and we're going to rotate it. So this is where we're going to have R1 over here, R1, and R2, and R3. All right, good. So we might as well plug the numbers in. So this is 470K, 470K. Okay. R2, 5.6K. Okay, and 10K. All right. Now we're going to add in 2 NPN transistors. Click up here to add a component. Look for NPN. Simulation SPICE, NPN. Perfect. So we're going to put one here. And we're going to duplicate that here. All right. Now we're going to need some capacitors. So the polarized capacitor. C-O. Polarized capacitor. Add that. down here. Yep. And we're going to add unpolarized capacitor. And that's going to go, say, here. All right. So C2 is 0.0022 UF. Did I get that right? No, I've got too many zeros in there. Zero 0.022. That's right. All right, and this guy is 10 microfarads. All right. Now we're going to have to model the auto transformer, and the way we do that is with two inductors and a mutual inductance. So we're going to add two inductances. Let's do that. They're just L, I believe. Inductor, yeah. I'm not sure why I have these KiCad unlocked symbols. I'm not sure. Anyway, I'll use them. I got them from Pat Deegan. I don't really understand what I did though. So we're going to add that there, and we're going to duplicate it here. Perfect. And we're going to need to add. Well, first of all, let's set up the inductances. So it's 96 millihenries. 960. I got that number, by the way, by using my LCR meter on the actual device, and I measured the two coils and they measured the same at 960. So maybe that's right, I don't know. Now we're going to have to add, we're going to go place text, and in here we say dot K1 L1 L2 0.98. I believe that's how it's done. I don't really understand what it is, but I believe that adds mutual inductance between those, which turns them into behaving like an auto transformer. I really don't know. I don't know. I don't know what I'm doing. So I don't know if this has any effect or not. It's quite possible that it does have no effect, and it's wrong. Maybe the dot doesn't go in front. I'm not really sure. If you know, I'd love to hear from you. And then for the piezo earpiece, I model that as a resistor and a capacitor as well. So let's just go back into select mode, and we'll move this across here a little bit. And now we need to add a resistor. So we're going to add a resistor. And we're going to add we'll add resistor, and we'll add the capacitor as well. There we go. All right, so this RC network models our earpiece, and this inductor network models the auto transformer. But I should say that that you can put in a series resistance here, and I haven't done that because I didn't seem to need it, so I didn't add it. All right, now the only other thing to add is this switch. So let's add, and we're going to add a switch. Now we want the SPICE simulation voltage controlled switch, so that's this. I'm going to add one of those over here. All right, now I'm just going to give myself a bit of space here. So let's move this across here, and move this down here. All right. So we're gonna have to add a bunch of wires now. So let's do that together. We'll place our things first. All right. With that, that. Might bring those a bit. Oh no, they're fine. And okay. So let's add in some wires for all of our stuff. Just going to save the board here. All right, so we're going to add wires. For me, that's Q. I press Q to add a wire. I'm going to just draw up the old. Okay, that's our voltage controlled switch. We're going to wire that in over here. And just going to move that up a bit. All right. I'm just going to get rid of those zeros on the ground. They're not adding anything to our thing. We know that's ground. All right, so this guy. Oh no, I've got that wrong, haven't I? All right, so we're going to delete that and that. And we'll just move all this up a bit. And these two are going to go there. So this one is across to there. And this one is to there. This goes on there. And this goes up to the top one. All right. And this one. Okay. Now this, it's gonna move that down a bit here. All right. So we're gonna have a wire from here to here to here. And we're gonna wire this in here and this in here. Looks pretty good. We're gonna connect the collector of the Q2 over to our auto transformer. All right, that looks about right to me. I'm gonna drop this in here. All right. This guy goes straight up to the top here. And the base comes in on this side. And then there's our 10 UF capacitor polarized. We just need to wire in the power supply over here. All right. Does that look correct and complete to you? It's kind of complete to me. So what we're going to be doing next is running this simulation. But first I'm just going to take a quick break. I'll be right back. All right, I'm back. Now, one thing I didn't do, I don't think it's actually necessary, but if we just open up this and we go to Spice Model, we can put the resistance when open, and I just put that up at like 10 mega ohms. I don't know if that was necessary, but that's something I did on the previous model, and I might just hide those as well because they're a bit ugly, aren't they? There we go. So the other thing to do, I'm just going to add two wires. I'm going to add a wire and run it out here. And I'm going to add a wire and run it out here. Now I'm going to add a net list. So place net labels. So I'm going to have one label. I'm just going to call it SIG, short for signal. And I'm going to put it here. And then I'm going to do another one. And I'm going to put it over here, and I'm going to call it out. So we're just going to call it out. Okay, and this will show what appears across the headphone. This is the headphone simulator. Oh, I haven't put in the numbers for this yet. Okay. So the capacitance is 8 nanofarads. And the resistance, well, I think it was 100 ohms. Yeah, 100 ohms. 100. All right, so we've got that properly specified now. Very good. Is there anything else that I'm missing? I'm not sure. But these are the points that we'll be looking at. So we'll see when the switch is on or off, because the voltage across here will change. And we'll see when the headphone pulses or not, and that'll be here. So let's save this and run our own simulator. So we're going to hit simulator. Now we're going to add okay. Why can't I add new analysis? Okay, and we're going to add just a transient analysis, and we're going to have 100 microseconds. We're going to run it for 10 seconds. Is that what I said down here? 20 seconds. 20 seconds. This is a transient analysis. Step is 100 microseconds. We're going to run for 20 seconds. All right, I'm going to save this. We want to see V out and V sig. All right, fingers crossed. We're going to run the simulation now. Hey, it's working, baby. So I don't know how well you can see this. If I just maximize it. Can you see that? I hope you can. So this faint blue line here, this is our DC pulse, which controls the switch, and this is the switch being switched in and switched off. Isn't it funny how we get this weird little behavior, though? I'm not sure what happened here. But basically, if we zoom right in, let's zoom right in here. You can see that we've got these recurrent symbols or spikes. So I don't know if I can zoom back out. Yeah. So basically this thing is oscillating like crazy. And what it'd be good to know is what the frequency is during this period, and then what the frequency is during this period. And frequency measurements is not something I know how to do in KiCad SPICE simulations. If you know how to use, there seems to be some cursor options where you can like measure things, which is all well and good. But what I really want is to know what the average frequency is through here and here. So if you know how to do that, please do let me know. And I'll just I'll put this back in a sort of reasonable kind of a thing. Okay. So there we go. That's our first KiCad SPICE simulation. We see our pulsing DC signal controlling our switch over here. So we switch on, switch off, switch on, switch off. There is a tone. You can see it's about 1 kilohertz coming through here. 1 kilohertz, by the way, because the distance between those lines is roughly 1 millisecond. So if it's 1 millisecond period, it's about 1 kilohertz cycle. Anyway, what we're going to do now is pop over to the booth and actually make this thing, and then we'll pop over to the bench and we'll have a look. And what we'll be able to do on the bench that I don't know how to do here is just get a report on the the frequency. We should be able to figure out that with the oscilloscope. So let's jump over to the booth and put this thing together. All right, well, here we are in the booth. Haven't been in the booth for a while. I only use the booth really for when I'm sorting out my resistors, which I seem to do more often than you'd imagine, and when I'm recording these Maxitronix videos. So hopefully we're back on board with the Maxitronix videos. Usually I try and get one done on Thursday. Thursday is Maxitronix day. Then we're not going to need that big honking bit of wire there yet, so we'll leave that for now. Just taking off the old what do you call this twisty wire? Twist tab? I'm not sure what you call it. Alright, so these are the longer blue wires, and then we've got some medium red wires, and then we've got a bunch of white wires. Alright, now the instructions are just pretty simple, so I'm just going to time lapse that with you now. Let's get this made. Alright, so that's all wired up, with the exception of the headphone, which is over on the bench. So let's jump over to the bench and we'll test this thing. Alright, here we are on the bench, and this is our circuit which we've just assembled. But before we look at the circuit, let's just look at the schematic. So I don't really know how it works, but it seems to be an oscillator, and it just sends out a tone, and there's, I guess, 2 tones. We haven't seen that yet, but that's what I'm expecting to see. When we close the switch, the tone will change and there'll be an oscillator across there. So let's have a look at that. All right, I'm back. Now what we're going to do is power this guy up. I'm actually a bit confused about the power there. I've made a mistake. Oh no. Okay, so it's just wired in for one battery, which is of course 1.5 volts. So let me just get the power supplies plugged in. All right, well, you can see the power supply at the back of the lab there. I'm going to put that on positive and put that on negative, and then we're going to set the voltage at 1.5 volts, and let's set the current at 100, not 100 amps. We want it to set current at 0.1 of an amp. It won't be anything like that, but that'll do. Now, the over voltage protection, we'll just set that up at 3 volts. So over voltage at 3 and over current at 0.1 as well. That's fine. Okay, so that's the power supply set to deliver 1.5 volts. So let's connect that over here. Can you see that? Yes, you can. Very good. So we're just going to wire in power. There's no battery in the back of this thing, so we're going to be providing the power through the power supply. So we're about ready to turn it on. So let's power him up. On we go. Oh, I suppose actually I'll just turn him off, and we should connect our speaker. Now, I don't suppose you'll be able to hear this, but you should be able to see it. You see, actually, I've got this connected to my. Just hang on one sec. Sorry, I'm just trying to get. What am I trying to get? Trying to get my OWON display, my meter. Do you see my meter up the top there? This OWON. I'd really like to get that display showing on my OBS studio. So I'm installing some software while I make this video as well. Anyway, as I was saying, I've got my Peak Atlas LCR45, which is a LCR meter. It measures inductance, capacitance, and resistance. And I hooked it up to this earpiece, and I got a resistance and a capacitance reading, which is what I used as the basis for the simulation in KiCad. So what we're going to do now is disconnect the LCR meter because we're done with that, and we're going to hook it up on the outputs of this circuit, which is 18 and 20. That'll be the final setups here. So 20 to earphone, 18 to earphone. So here's our little tabs, and let's just put these together. So 1 and 2. Now I've got the earpiece in my ear. Here's the lamp out of the way there. So I'm listening. We'll put the on. All right, we're not hearing anything. Nothing. Oop, there it goes. Well, it's making a really loud whirring noise, but it's not changing much. Yeah. All right. I'm just going to turn it off because it's making a hell of a racket in my ear there. All right, so the key didn't seem to make much difference, but it's certainly oscillating and emitting a tone, but it's not a really big difference. When I press the key, no big difference is heard. Maybe there's a loose wire, I'm not sure. Well, I'm just going to quickly run over all of the connections here. I'll do that off camera. I'll be right back. All right, well, what I'm going to do is actually buzz out the whole circuit. So I'm going to do that in fast forward mode with you now. All right, well, that's done. I just buzzed out all the connections. They're all connected correctly. One thing that I might do is insert a variable transistor in the space where we'd ordinarily have the 470K. So I'm going to try and install a 470K resistor replacement. So let me go and find something suitable. All right, well, I found this. This is a 1 meg potentiometer. So it'll go from 0 to 1 meg, which is a huge range. And 470K, it should provide a pretty good range of resistances. So what we've got to do is put some leads on this thing. So let's fire up the old soldering iron, and let's put some water in our sponge. Won't be much soldering that we're doing today, just a little bit. What we're doing is the same thing that we've done here. You see I've got this 10K potentiometer and it's hooked up like that. So we'll be doing the same thing. Just need to find ourselves a suitable bit of wire. How about blue? Blue looks pretty good. We've got a nice long blue. Oh no, it's not that long, is it? Maybe we'll just use, oh no, that's a fairly long blue, isn't it? Yeah, that's a ripper. All right, good. So we'll just put that out of the way. Now we're going to cut this in half, and then we're going to just attach it to one end. They do say that you should connect the wiper. I don't know why they do that. I remember reading that in the in the book. Are we going to do that? All right, so chop that off there. Now we're just going to need a little bit of insulation stripping, so let's do that. I might actually just do this on fast forward with you now. I'm going to take these and attach it to this. Let's get that done. Right, so that's our 1 meg potentiometer all dressed up and done. I did actually connect the wiper to the other side because it told me to do that in the book that I'm reading, Learning the Art of Electronics. I forget the justification for that. I don't remember. What we might do just quickly though is just let me find oh, hang on. I think I've got it. All right, so I'm just going to switch out the old, I've put this in, oh, it is in resistance mode. I'm just going to take out the jumpers I was using and plug in the old hook clip. These are the hook clips I'm plugging in now. And then we should be able to just hook up to our new potentiometer over here and just check that it gives us readings from 0 to 1 meg, which it should, assuming everything's worked correctly. Oh, it's on the wrong way. There we go. All right, so that's down at 1 ohm on the low end, and let's turn it up. It's gone up to 100k, 200k, 400k, 500k, and bang, 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 1.017 megs. All right, ripper. Now, the insulation on here is not real good. I wonder if I could do better. Give me a second, I'll be back. All right, I'm back, and I found I've got heaps of heat shrink. It's all over the place. Why don't we use light blue? What do you think? And we'll just put a bit over the bit there. So let's chop off how much? Say that much. All right. I haven't used the big stuff before. I usually just do it over 1 wire, but here we're going to go over 2 or 3 wires. Should be good though. All right, so we'll just feed him through there. Up we go. All right, I don't know how this is going to work, but I guess we'll find out. It might actually even be too big. I hadn't imagined that it would be, but it might be. Let's see what happens. All right, well, it went over that bit quite well, but this bit's a bit sloppy. I don't know if we could do another one. What do you think? Maybe we could put another slightly less wide. What about this? Let's give it a go. How much are we going to use? Say this much. It's the same color, which is good. So let's see what happens if we add that. All right. I'll just time lapse this and we'll do it together. All right. Well, it gets better and better. Do you think we should even go for one further? I don't know. I don't know if we'd be able to get it all the way over. There is another blue size here. I don't know if we'd be able to get it over. Probably not. I'm not sure. Maybe if I cut it. I don't know. Am I being silly? I'm not sure. No, I'm not going to do this. It's not a good idea. I wonder though, is there something that this yellow one might be good? What do you reckon? I don't know. Don't know. All right, I'll do it. Let's time lapse it. All right. Well, it looks fairly well insulated to me. So this is our 1 meg potentiometer. That's a good job. Well done. So let's replace the 470 kilo ohm resistor. What have we got here? There we go. What are we trying to do here? I'm going to replace the 470k ohm resistor with this 1 meg potentiometer. So we've got 470k is between 43 and 22. Okay, so let's just disconnect it for now, and we'll hook in our 22. There we go, and put him underneath. All right. So I'm going to power this up. We'll power him up, and we'll wait for a minute for the earphone to start beeping. Oh, it's not making any noise at the moment. Let's try pressing the button. It's not making any noise. Oh, there it goes. Gee, it's loud. All right, I'm going to try varying the, yep. Man, I tell you that that thing is really, really loud. I actually I think I might have even damaged my hearing. I can't hear properly. That thing was really blaring. It does change the tone, but then it doesn't go back. So I don't understand how this oscillator works. I really don't get it. I haven't seen. I don't think it's an astable multi-vibrator. It's something else. I don't know how the coil affects it, the capacitors, the transistors. I don't know. I don't know how this works.
but it just seems to oscillate at sort of like a fixed frequency. The 470K resistor, which I've replaced with this 1 meg pot, does affect the frequency, but not in the way that I thought. Like I thought if you turned it up, it'd go up. If you turned it down, it'd go down. But instead it seems if you change it, you press it, it goes to that level and then it stays there, seems to be. Anyway, what we're going to do is, first of all, let's look at the thermals. Let's just get that done. So, all right, so let's throw you over to the thermal cam. And we're looking at the circuit here. I'll just put it so that it's all in view. All right, so what are we looking at? This is the back here, and this is the circuit. So this is the key that you can see reflecting there. All right, so okay, there's a bit of heat in the top transistor, isn't there? Let's try pointing at some things. So what's this? What's this? Seems to be, when I touched it, it affected the sound. Trying to keep my temperature out of the thing. So it seems to be warm in this region here. Sort of diffuse warmth though, isn't it? Yeah. Something, what's, oh, this is the reflection off the top of the transformer. That's what we're seeing there, it's just reflection. So yeah, seems like the heat's sort of diffusing out of the transistors really, but it's only drawing like 0 amps, so 0 milliamps. So who knows how much current this is drawing? I suppose we could find out. Let's get a current reading. Hold on a sec. All right, so that's our circuit in being measured as current. So we're looking at about 170. Seems to be going down, 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 down. That's interesting. And if we press the key, the power will change. It's gone up to 230, release, and it slowly falls away. So yeah, it's quite odd. I don't understand this circuit at all. Press it, it goes up again, draws more power. So okay, that's our current reading, about 200 microamps. And let's get some readings on the oscilloscope. So let me just go and get the cables. All right, so we're going to put our negative on negative, and we're going to probe just one side of the earphone. So let me throw you over to something that you can see. All right. So that's our in the corner here. That's our oscilloscope. I'm just going to hit auto mode, and we'll see what we're looking at. It doesn't look real good, does it? Let's see if we can. I don't know why I'm not getting a good reading. I'm just going to go and get some more coffee. I'll be back. All right, I'm back with my coffee. I actually already had one. I just found it on the other bench. So I've been playing around with this reading on the oscilloscope up the top there.
and it's kind of ugly, isn't it? I added a frequency counter. You can see that in the bottom left, just there. And that frequency seems to be jumping around quite a bit. It goes all the way down to about 200 hertz, and it goes all the way up to about 1. I don't know what happened. If we press the button, let's see what happens. Oh, there we go. That changed quite a lot. And the frequency's gone to a steady 1 kilohertz. Interesting. 1 kilohertz is what we saw when we did the simulation. So let's try auto calibration again. It really doesn't, it can't, oh, there we go. Okay. See if I can just move that trigger up a little bit. Up, 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 up. Okay. So the frequency's still a bit skittish, isn't it? Yeah. So, not sure what to tell you about that, but obviously the tone, there is enough oscillation to actually make a noise, but it's not a nice clean oscillation at all, is it? Really? Anyway, I think that concludes our investigation. We've looked at the thermals, we've looked at the scope, we looked at the current. We powered it off the bench power supply. Yeah, I think we've had a pretty good look at this circuit. We switched out the 470 kilo ohm resistor for our potentiometer here. Oh, look at that. Interesting. Yeah. Just playing with the resistor here and seeing what it does to the waveform. Yeah. All right. I'm going to throw you over to the farewell cam and we'll wrap up.
That's a wrap. So, at last, the first project lab of our 30in1. Kicking all sorts of goals around here lately. Got our first learning the art of electronics lab done. Got our first 30in1 lab done. Happily, we did the SPICE simulation. We saw basically what we wanted to see. In fact, I think even the SPICE simulation was better than the circuit itself. Yeah, we did see that little oscillator. It's a crappy oscillator with a real dirty, uneven signal, but it made a tone. The frequency wasn't as affected as I thought it would be by the 470k resistor, which we switched out the 1 mega ohm resistor for, but it did affect it, but then it kind of had a holding pattern. I don't understand this oscillator at all. If you know anything about the oscillator that we've just made today, let me know about it. I'd love to hear. Yes, I think that concludes our video. We did the simulation, we did the build, we did the test, we checked all the things. So we saw the current draw, we saw the voltages, we saw the thermals, and we had a look at the signal with the scope. So all in all, very successful video, I think. What do you think? Let me know in the comments. Are you excited to get going on the 30in1? This is our first step out of 30 that we'll be making. Thursday is learning the art of electronics. Oh, Tuesday is learning the art of electronics day. Thursday is Maxitronix day, and that'll be Maxitronix 30in1 until we're finished. So that'll leave us free to do things on Saturdays, and I've got a whole lot of mail calls coming up on Saturday for a while now. And of course, I've been threatening to do Maths Monday, so maybe we'll do Maths Monday as well. We'll see how we go with that. Anyway, that concludes this video. Thanks very much for watching. Hope you enjoyed this video, and please remember to hit like and subscribe.